The last thing we're going to change about our array list is to make it generic. Now there wouldn't be anything to do, I wouldn't even make this video, if it weren't for one little syntactical quirk of Java, so let's see it pop up. So I need to, in order to make my array list generic, I of course need to pick a type parameter name. I could pick blorp or whatever, but I'm going to pick item, which is a little more common. Now there's nothing special about putting item here. It's not like a special keyword in Java, it just happens to be the one I'm going to use. Now I'm going to go through and I'm going to say, instead of it being an int array, it's going to be an item array. A list, instead of being a new int array, we'll say new item, 100, let's say. As we move our way forwards, when we resize, let's see, what else do we need to do? Okay, this should be an item array. Continuing to move forward, everything here looks good, except add last needs to take item. Get last returns an item. Get returns an item. And remove last will return an item as well. Okay. So we'll notice there's actually a couple of syntax errors, and we see that Java is complaining. In fact, if we hover over, we see item cannot be instantiated directly. Item cannot be instantiated directly. Required item found A. Okay, well that one we can change. Okay. So what does this mean? Item cannot be instantiated directly. There's an annoying feature of Java, which is that generic arrays are not allowed. You simply cannot do them. So instead you have to do, and just trust me for now, this very strange thing. Instead of saying new item, we say new object. Okay. Now when we do new object, it now says required item but found object. No problem. I'll instead do this other mysterious thing where I'm going to type the word item here, put the braces, and now things will work. This is a cast. We'll learn about casts later, but for now that's just what we need to know. This is just a side effect of the strange way that generics were created in Java. And so effectively what it boils down to is, instead of saying new item yada yada, in Java we have to do parentheses item braces space new object. Okay. And that's only because Java specifically does not allow you to create arrays of generic objects. So at this point, our code should compile, except that we should have made this into an item as well. Okay. So now we see everything. We see no compilation errors. And in the real world, again, we test, but not in this lecture. And so we end up with a nice array list. So this on the left is our array list code that holds only integers. And this right here is our array list that holds arbitrary things. I used glorp on the slides, I used items before, and the only really interesting thing is this. There's one more interesting detail, which is that, well, actually maybe I should summarize real quick. So in a sense, our issue is that when we create an array of references to glorps or items or whatever, instead of saying new glorp, we say glorp braces new object, however many items. This will, by the way, if you use the command line compilation, it'll give you a compiler warning, and if that happens, you just gotta ignore it. It's a thing we have to deal with because of the funny way that Java was created. If you did actually do new glorp, you will get, if you use the command line compilation, generic array creation error, and we'll talk about these funny language issues later, but for now, they're just not that interesting. I wanna focus on the interesting stuff, and we'll deal with Java minutia in the future. Now there's one other thing we do want to change about our code that's a little more subtle. So what we had before will work correctly, but it does something called loitering, which I don't like. So unlike integer-based A-lists, remember whenever we're doing the allegory of the cave, we did not actually destroy the bird that someone finger shot. We didn't actually overwrite things with zeros. Now actually, we do want to overwrite things. So the difference is we are actually going to say items size -1 equals null. Okay, let's just get that down. So after we get the last item, we will say item size -1 equals null. So why are we shooting the bird here? What's going on? Well, the issue is, imagine here we have an array that happens to hold pictures of loitering signs. So in position 0, we have this one. In position 1, we have this one. In position 2, we have this one. So remember that Java only destroys unwanted objects, only does garbage collections when the last reference has been lost. If you keep a bunch of reference around to unneeded objects, then that object will persist somewhere in memory. So this image could actually be maybe a megabyte in size. And because you're keeping the address stored of this object, Java will never delete it. So this is considered loitering. And so by setting this thing to null, what will happen if we say if we don't set this to null, when we reduce size to 2, then there's still a link. Look at that. It's horrible. And so basically we're wasting all this memory storing a reference to the sign image, and we just have this Getty images thing laying around. By contrast, If we null this out, then the garbage collector can come around and say, you know what, nobody actually cares about this image anymore. I may as well destroy it. So it's a very subtle point you might never notice unless you're storing objects, storing an array of really large objects. But we do need to do this when we're using generics, otherwise we're loitering. So don't loiter. And you might really go back to earlier and think, what was special about objects versus just integers? Make sure this really makes sense, because it's a subtle point, but an important one.